Ooh, math geniuses. I love math so much. Ooh, how do you live without math? It's so awesome. Yeah, math geniuses. We're the math geniuses.
So now I'll be describing the general form of a linear equation. We have ax plus by plus c is equal to 0. And in our equations, a, b, and c represent constants. The x represents the independent variable. This is the one you'll normally be graphing on the horizontal axis. And the y represents the dependent variable, which means you get the y value by plugging in different values for x. And the y gets graphed on the vertical axis.
So, you want to show them how to derive the what is it? The slope-intercept form?
Yeah, for sure. Alright, I'll just make our equation a bit smaller.
Alrighty. Just tell our viewers what you're about to do.
So right now what I'm going to do is rearrange for y. I want to get it into a form where we have y equals mx plus b, where m represents the slope of our line and b represents the y-intercept.
Hence, slope-intercept form.
So, to start, I'll be moving the ax and the c to the other side of our equation. So when we do that, we end up with by is equal to negative ax minus c.
Well, how'd you do that?
We simply take the negative of this term here and this term here on both sides. So once we minus this term from itself on this side, it becomes 0, and the same for this term here. And on the other side, we start at 0, so we just simply get the negative of each of those values. So to isolate our y here, we're going to want to get rid of this b. So we'll divide by b on both sides, and we'll end up with y equals negative a over b x minus c over b. Here we won't really worry about the negatives at this point. We can make our variables our constants a, b, and c either negative or positive. So the negative signs don't really matter at this point. So comparing to this equation up here, we have our y equals negative a over bx, and in here we have y equals mx. And comparing again with this, we have our little b, which is the y-intercept, equal to negative c over b. So this becomes our y-intercept. So we end up with y equals mx plus b, the slope-intercept form.
Oh wow. So we went from general form, and we did a couple manipulations, and it's all the same thing, and it ended up in the slope-intercept format.
Yes.
Where this m right here is equivalent to the negative a over b, and you got the b, lowercase b, equal to the negative c over b. Okay, so now we're going to be doing the point slope form. To do so, we have to first take into hand that for this type of equation, we're given a point, and we're also given a slope, hence the name point slope form. And then we're going to rearrange it to the point intercept form. So here we go. We're going to start out with the point 1, 1 on this Cartesian coordinate graph, and then the slope that we're going to be given is m equal to negative 1. So now that we go over to the equation, the general format for this equation, which is y subtracted by y naught, which is equal to m, the slope, multiplied in parentheses x subtracted by x naught. And in this case, our x naught and y naught is going to be equal to 1, 1. So you know that this is going to correlate to that, and then the 1 is going to correlate to the y naught. So now all that's left to do is plug it into the equation and rearrange it now. That's what we're going to do. So y subtracted by y naught, which is 1, is now going to be equal to n, which is negative 1, multiplied by x subtracted by x naught, which is also 1. To get it equal to the y equals mx plus b form, also known as the point-intercept form, we're going to add 1 to this side, and add 1 to this side. Hence rearranging the equation to y equals negative 1 x subtracted by 1 plus 1. Because this right here comes right there. And then these, after doing that, we now need to simplify a little bit. So we're going to have that y is equal to, by distributivity, negative x plus 1 plus 1. So we get that y is equal to negative x plus 2. And in this case, we put the 1 there so that you can all see that this is what our actual slope is going to be equal to. So bringing it back over here, we know that this line is now going to be y equals negative 1 x plus 2. That means that this intercept is going to be at 2. The slope is negative 1, so down 1 over 1, down 1 over 1. Or well, in this case, it'd be down 1 over 1. Alrighty, so now we're going to go into an example. A common problem when dealing with these types of math equations. I'm going to give our friend Evan here 2 points so that he can solve the equation. So how about we use 3, 2 and 5, 1 to solve for a line. So now what is Evan going to do?
I'll first plot out these points here. So we got 3, 2, 3, 2. We got 5, 1. So now the slope formula. Slope is equal to rise over run. So with these 2 points here, we got our rise is the difference between 2 and 1. So we take this equal to 2 minus 1 over the run, which is from 3 to 5 here. So we got 3 minus 5. So we simplify this to 1 over 2 with our negative sign here. So we got our slope equal to negative 1/2 here. So we got y equals to negative 1/2 x plus b.
Yep. Now, how are we going to solve for b? There are 2 instances, or 2 different numbers that we could plug in.
Okay, so we'll take this first point here. So we'll put y as 2 equal to negative 1/2. Y is 2 equal to negative 1/2, and we'll plug in our x value, plus b. So we multiply this out. So we have 2 equals negative 3 over 2 plus b. And I know all you guys love fractions, so what we gotta do is add 3/2 to both sides. So making 2 into a fraction, we have 4 over 2 plus 3 over 2 is equal to 7 over 2. Or if you wanted in decimal form, this would be 3.5. Sorry. And that is equal to our y-intercept. So plotting this whole line here, our y-intercept will be at 3.5. So I'll try to draw a straight line here. So our final formula for this line will be y equals negative 1/2 x plus 3.5.
Ah, wonderful. Okay, so now we are going to just do another example of what Evan showed us earlier. General form with number examples, and then moving that into the point-intercept form.
So I'll give my friend Kimmy here some numbers for A, B, and C. We'll just make it easy and go with 1, 2, 3. So A is equal to 1, B is equal to 2, and C is equal to 3. So then Kimmy will write out the general form.
So here we have 1 multiplied by the x plus 2 multiplied by the y plus 3. And this is all going to be equal to 0. So to manipulate this equation, like what Evan did before, we're going to just subtract 3 from both sides and subtract the ax as well. So we got negative 1x on both sides. So these cancel and these cancel. We're going to be left with 2y equal to negative 3 subtracted by 1x. So the next step that he did was just divide each side by the b component, or coefficient in this case. So we're going to divide the entire equation by 2. So we're going to end up with y equals negative 3/2 over negative 1 over 2x. Rearranging it, we'll get the point-intercept form, negative 1 over 2x subtracted by 3 over 2. That's all going to equal y.
We hope you enjoyed our video.